Hey DSA Math 1 students, welcome back. This is day 2 representing data with scatter plots and functions. I'm Miss Hamilton, and in this video we're going to get a quick refresher on linear and exponential models. We're going to learn how to do regression if you don't have a graphing calculator at home, and then we're going to do a couple of questions from your supplemental packet. So if you don't have paper and pencil right now, pause the video, go grab some so you can take good notes. And then once you're done, I encourage you guys to go to the day 2 Google form and try some of these practice problems on your own. All right, let's get started. So a quick reminder about linear models. So linear models obviously look like a line. And our function is generally in the form f of x equals ax plus b. X is our independent variable. So whatever in the problem is kind of the thing that we have control over, or the thing that is controlling the dependent variable or causes change in the dependent variable. That's going to be our x value. And then f of x is our dependent variable. You can use y as well, just this is how it's written in function notation. And then a is our slope, so our rate of change, and b is our y-intercept, or our starting value. So on our graph, the b value is going to show up here at our y-intercept, and then our slope is our rate of change. So remember, change in y over change in x. Change in y over change in x. That's how we calculate our slope. All right, so you guys have been working with linear functions for several years now, so I feel like this is what we're more comfortable with. So let's talk a little bit about exponential models. This is, I think Math 1 is the first time you guys have seen exponential models, and we did this a couple of units ago. So a reminder about exponentials is they kind of take on that smooth curve. They've got that L or J shape. And once again, x and f of x are just the independent and dependent variables. So depending on the problem, that would tell you what these are. Our a value is our starting value, or our initial amount, I guess is what we called it. And then our b value is our growth or decay factor. So that's just telling us what we're multiplying by each time. So it's saying if our equation was like y equals 2 times 3 to the x, this tells me that I'm starting at an initial value of 2 and I'm multiplying by 3 each time to get to my next value. In our graph, that starting value or initial amount generally shows up as our y-intercept. And then our growth or decay factor is telling us how quickly or slowly our graph is growing. All right, so we learned that if we were given a set of data, we were able to find linear or exponential regression using our TI-83 or TI-84 graphing calculator. So I want to do a quick reminder of what that looks like. So in your graphing calculator, we went to Stat and Edit, and then you would type in your data. I'm just going to do some random numbers so that it'll give me something. So like this. And then in order to get a linear exponential regression model, we go to Stat, we go over to Calc, and then if we want linear regression, we pick option 4. If we want exponential regression, it's further down at option 0. And once we select one of those, then if you've got the newer version of the calculator, this is what shows up. If you've got the older version, you can just hit enter right now, and we'll scroll down to calculate and hit enter. And then remember, we have to be able to translate this into the actual equation. So we would plug in 4.3 for A and 0.98 for B. And then we could write our equation y equals 4.3 times 0.98 to the x power. All right, so the issue is some of you guys may not have a graphing calculator with you right now. So what I want to show you guys is how do we still find regression, but using something called Desmos instead. So this is something that you guys should have access to if you've got a computer or a phone with an internet connection. So we're going to learn how to use Desmos with doing this example problem. So doing question 2 together. So question 2 says Jennifer works at a local printing press. She records the number of newspapers sold every week in the table below. Use technology to determine the exponential equation that best represents the data. Then predict the number of newspapers that will be sold after 10 weeks. So the key here is we are gonna want an exponential equation. Sorry, I crossed that out. I meant to underline it. But an exponential equation is what we are looking for. All right, so here's where it might help you guys to kind of pause the video as we're going so that you can try this on your own as well, especially if you haven't used Desmos before. So if everybody will go to desmos.com, you should see a screen that looks like my screen right now. And then you're going to hit Start Graphing. Okay, so when we're trying to find regression, the first thing we need to do is we need to make a table. So you're going to hit the plus sign right here, and then it's going to give you the option for table. So I want you to select that. And then you guys would go and you would type in the data that we see. So in question 2, sorry if I can get back here, it looks like the first week, week 0, it's 600. So in our table in Desmos, we would type in 0 and then 600. And then we just hit enter and we type in more numbers as we go along. I don't want you guys to have to sit and watch me type these numbers in, so I've done that for you. And this is what our final table looks like. So then how we take this, and if you notice to the right, we see those points plotted on the graph. How we take this and we actually get a regression equation is we go down here to the second option. So this right here, and we need to tell our calculate our Desmos, whatever you want to call this, that we want an exponential regression equation. So what we do is we type in y and then a 1, because that's what it shows up as in our table. It's y subscript 1. And if you just type the 1, it'll put it as a subscript for you. So y1 equals, and then we want an exponential equation. So we need to think back to that exponential model and what that setup looked like. So with an exponential equation, it was a and then times, let's see, where are my parentheses? Times b. Sorry, y'all. I'm a little new to this. And then raised, so when we want the exponent, we do the caret key, which is somewhere. Oop. There we go. Right. There it is. Okay, so we do the caret key and then to the x1 power. Okay, so we get this. Oh, and I'm sorry, this equal sign. This is where this is the important part. So in order for Desmos to know that you want to do regression, you use the little tilde key instead of the equal sign. So this key right here. There we go. I'll get better at this. Okay, so now if you notice, we have y1 tilde a times b to the x1. So this, they drew in our exponential regression model, and then below we can see what those a and b values are. Now the issue with Desmos is they're actually using a different calculation than our graphing calculator would. So the way that we make this match up with our graphing calculator is we check this box that says log mode. So you have to check the box to make sure that our final answer is correct. But when we do, we see that we have an exponential regression equation, and that exponential regression equation has an a value of 750.298 and a b value of 1.13594. So if I wanted to go back and write my equation for that particular problem, so my equation for that model, it's going to look like this. So y equals Our A value was 750.3. And our B value was 1.14. So that's so if we look at our answer choices, the only one that matches up with what we're doing right now is B. But I do want to show you guys how we get this part. So it says, how many newspapers will be sold after 10 weeks? Since X is our number of weeks, we're going to plug in 10 for X. So we would have Y equals 750.3 times 1.14 to the 10th power. And if we type that into our calculator, or you could type this into Desmos, you would get 2,780 newspapers. All right. Last thing I want to show you guys for this question still is in Desmos, we talked about how to do exponential. If the question was asking you for linear regression, you can do the same thing. So you can do y1 and then the little tilde. And then for, sorry, so y'all can see it, for, all right, y1, tilde. For linear, it's ax plus b. So we'll do a and then x1 and then plus b. And it gives us the linear equation. If you notice that green line showed up, which is our line of best fit instead of our exponential equation of best fit. And for the linear, there's not a log mode box to check. That would just be your final equation. So you'd plug in 194 for A and 683 for B. So this is how you can do regression on Desmos instead of using your calculator. So you type in your data by going to plus, picking table, and then type your data in the table they give you. And then to actually get your equations, you type in the general form for an exponential or a linear equation with the little tilde key, and it'll pop up your equation for you. All right. I know that was a lot, so if you have questions on the Desmos part of it, please feel free to ask those in the collaboration document, and I will do my best to try to answer those, and hopefully your classmates can help you out as well. All right, last question we want to talk about is question number 6 from your packet. So it says the exponential function shown below can be used to model the data f of x equals 63 times 1.12 to the x power. We're using this question to answer the following 3 questions. So the first one is based on the model, there were blank cases reported on day 0. So if we look at our graph, day 0 is here. If we look at our model, day 0 is here. So we're seeing that at day 0, there are approximately 63 cases reported. Then we're supposed to know how many were there by day 14. So days are our x values. So let's plug in 14 for x. So 63 times 1.12 to the 14th power. And that is going to give me approximately 308. So there were 308 cases on day 14. All right, finally, this is the one that gets a little bit tricky. It says, based on the exponential model, there were 850 cases reported by day blank. So this time, if we plug in to where it's supposed to go, let me erase some of this. So our y values this time are reported cases. So they're giving me a y value. So if I plug that in, I would have 850 equals 63 times 1.12 to the x power. This is not something that we have ever taught you guys how to solve. So what we need to use is our other resources that are available to us. And in this case, that is our graph. So what I want to do with the graph is I want to look when y is 850. So that's right here. What is my x value? So here's the point on the graph. If I go down, I see that my x value is at about, well, it's right between 20 and 25, so 22.5. Not sure if they want a decimal or not, so about 22 and a half days. All right, so this is kind of showing you guys that you can use both the model in equation form and the model in graph form to help you answer some questions today. All right, so please, if you've got questions, add it to the collaboration document. If not, please go ahead and go to the Google form and try those questions. Remember, once you hit submit, you'll get some feedback on any of the questions that you did not get correct. Hope everybody's doing well, and we'll talk to you guys tomorrow.